Hello, Hackathonians! I am Shahriyar Shahini, PhD candidate in the Department of Chemical and Biological Engineering at UB. I am joined by Kevin Saleh, a senior software engineer that builds fantastic user experiences and automated workflows. The problem is that omic technologies generate massive data volumes, and there is a lack of a standardization that makes it difficult to reproduce or compare results across different studies. Data interpretation is time-consuming and difficult, and the progress of biotech lags despite the tech advances. Our vision is a world without sickness and decline, where personalized medicine eliminates aging and diseases before symptoms appear. Researchers can upload any omics data for analysis. All the omics data are automatically analyzed simultaneously and combined to generate a holistic view of the biological system. This will make sophisticated omics insight available to all researchers. And this would transform data into clear, concise insights to accelerate drug discovery and patient care. Our solution is the automation of this process, where machine learning processes large datasets and standardizes workflows. This would allow instant exploration of findings. AI assists in understanding complex biological findings, and it suggests interventions for researchers to take advantage of.
If you go to the methodology page, there's a bit more information about the full analysis pipeline that we run. It was run across 3 datasets, so not all have the same steps. And it's Python scripts, and the process is still somewhat manual to get it done for any dataset. It takes about 30 minutes to an hour to run for a new dataset that is similar to the ones tested. But some steps are really common. Like the first one is to process the data and quality control to normalize and standardize it. Then there's UMAP clustering and characterization of clusters and selection for deep analysis. Then we validate the clusters with some stability validation, and one of the most important steps is to build this network analysis, so we can build a network of the different genes that is helpful to navigate from gene to gene. Then there's a few other steps that allow us to characterize the genes, to find pathways and go terms, and other steps that allow us to score the genes. For different datasets, there are different ML analysis that can be run. In this one in particular, since it was temporal dose based, we also ran temporal dose response analysis, responder analysis, and gene type classification.
Here I am going to give you a live view of our project. On this page, we have the type of the project, which has like 15 samples with different time points, and it includes young and senescent cells and also nano treatment or partial reprogramming. Kevin have made this amazing chatbot on the overview page, and you can ask anything from the chatbot. The example here is that which biological processes are changed with senescent and what is reversed with nano. AI suggests cluster 7, which is senescence markers like CDKM1A or P21. On the gene page, there is a functional network graph that you can interact with it, and you can click on any genes on the graph and go to that genes page, read the graph again to interact with other genes that are associated with that particular gene. You can see the network connections, and as you can see, PLK4 is connected with that gene. If I click on this gene, I can go to that page. Kevin has developed this fantastic AI synthesis writer. This AI integrates user input data and analysis with extensive literature search, and provides a detailed report based on the data and suggests interventions. So for example, here I asked how is this gene affected by NANOG and what are the other genes upstream that affect this gene. I just put the user-specific question answers. So this is giving me some idea of what is happening, like P53 pathway and DNA damage response. And also it shows me that is the top co-expressed gene, which is oxidative stress response. The social impact of this platform is that it converts the week-long analysis bottleneck into instant actionable insights. This would remove the bioinformatics barrier and empower the hundreds of non-computational labs to enter the R&D space easily. This would increase the chance of breakthroughs significantly. This platform can be used with any other diseases or treatments. For commercialization of this platform, we have solved a problem that biotech is facing, and that is large costs and large waiting times due to outsourced bioinformatics labor. We propose immediate standardized multi-omic analysis at a very competitive price. I hope you enjoyed this platform as much as we did. I want to thank Kevin for all his time and effort to make this happen. Looking forward to your feedback.